Hello, everyone, and welcome to the Lesson 10 guided example. Hopefully you've had a chance to read through this slide. If you haven't, go ahead and pause the video, read through it, and then come back to the video. You can also click on the audio file if you'd like to um, have me read along as you read to yourself in your head. So I'm going to look at the most important information in the context. So I see there's an amount here, 20 cups of blueberries. And so I'm going to highlight that. And just a reminder that you can highlight different types of things with different colors or the same color. It's up to you. It can be very helpful sometimes to highlight them differently so that when you see them later on in other word problems that are related to it, you can make the connections that you need to. For every is a key word, it is not an amount. And so it's really important that you underline that rather than highlight. So you can press Control U once you've selected it, or you can press the little U that's up here to underline. And then I see another amount, 30 cups of strawberries. I'm going to highlight that with blue just so that I can keep track of blueberries versus strawberries. So today we're going to continue our work with tables, ratio tables, but we're going to look at it in the context of how can we use them to go backwards, and how can we use them to make sure that we're actually using the ratio rather than just randomly putting in numbers that we think might work. And so I'm going to begin by looking at this picture that Antonio, a make-believe Antonio, not a real Antonio, created. And so he compares the cups of blueberries to the cups of strawberries. And our goal is to first analyze it, see what's going on in it. Second, we're going to see what parts of this are accurate and what parts are not accurate or need some revisions. And then finally, we're going to make the changes that need to happen by reading down below. So I'm going to begin with the labels. The labels looked great. He's comparing cups of blueberries to cups of strawberries, and that's, since they didn't mention any specific order, we can use the order from the story. So cups of blueberries, and then cups of strawberries. And this is something that he already did well, so we're not fixing his work just yet. And those are the labels. So I'm going to bring these little check marks, and I'd like you to do the same thing. Normally these are for me, but we're doing this part together. So you can bring the check marks over here to let Antonio know, yes, you did good labels. You put the correct words that help us to compare the ratio. Second, the accurate given ratio. So if he starts with cups of blueberries, he needs to start with 20. And I see that in his table, he did that. So I'm going to put 20 here. And then for strawberries, you need to put 30, and he did that. And so I'm going to bring the little check marks over again and make sure that he is getting that feedback, that he was on the right track. He put the correct labels to begin with. He put the correct ratio to begin with, 20 to 30. If you're not quite sure how I'm moving these check marks, what you can do is click on one at a time and use the arrows to move them over. I like to move them at the same time, but if you don't know how to do that, that's okay. I open a box around it, and then I let go, and then I move them both at the same time. But that's not required for you. All right, so the next thing is we need to see if he continued this. So if the equivalent ratios are accurate. So he went by, it looks like tens on here. So if he's going by tens down the way, then we need to figure out what we would need to count by for the strawberries. Since this doesn't actually start with 20, this is a little bit trickier. So we're going to find the third ratio first. So we have the first ratio. We're going to find the third ratio by doubling it. And so over here, I'm going to put times 2 times 2. So whatever you do to one part of the ratio, you have to do to the other. So if I'm going to jump down, knowing that this is more like counting by 20s, I'm going to assume that he was okay in doing this, but see if he was correct on this side. So this would be 20, and then down here we'll put the 40 just like he did, and the 30, and the 50. But then we're going to multiply from here to here. So that's doubling. So that's multiplied by 2, and then multiplying this by 2. So 2 times 20 is 40, which we have. And 30 times 2 is 60. So I'm going to put 60 here. Well, if I compare that, he had 50. So that means he was counting incorrectly. It looks like he might have been counting by tens on both of them. And that's not how ratio tables work. Ratio tables add by a different amount on either side, but then it's consistent all throughout. So if he's going to be adding by tens here, he needed to figure out what to count by here, because he can't just count by the same thing. It's a different number to start with. So this is one way. You can multiply to get to different amounts. So I multiplied this by 2 to get the 40 that he wanted, but then I had to do the same thing to the 30 to get the 60 that should have been there. And so I'm going to put that his ratios are not equivalent because right from the beginning, he already has the third ratio incorrect. And if I look at the second ratio, now what we're going to do is figure out if 30 is in between 20 and 40, then what number would have to be in between 30 and 60? And so to do that, what we're going to do is we're going to scale backwards first from here, and then we're going to move forwards with that. So if I scale down, take half of this, then you're going to get 10. And so then that means that there's really a missing row here of tens. And so then if I count by tens, that's 10, 20, 30. So I was counting by taking half and then doing 3 of them, multiplying by 3. So if I do the same thing for 30, I need to take half of it, see what would come before, what would be I'm actually counting by to get to the 30. So half of 30 is 15. Another way to think about that is dividing the 30 by 2. You get 15. So then if I count by 15s, 15, 30, and then add another 15, I get to 45. I'm going to pause here for a moment, and I recommend that you pause the video as well so that you can fill in whatever you have gotten so far. Okay, so hopefully you were able to pause the video and fill in up until this point. We're going to continue with this pattern now. So if I continue, this is 20, 30, 40, 50, because we're actually counting by tens. So then the next one would be 60, which is not in his graph, or his table rather. So then we're going to be consistently counting by 15s on the strawberry side, because remember that there's that missing or invisible row at the beginning that is actually saying that there's 15 here. So 15, 30, 45, 60, at another 15, you're at 75, and at another 15, you're at 90. Okay, so then this is a consistent way to count. He could have also just, and you could have also just fixed his work by just saying, I'm going to count consistently by the numbers that are actually here, rather than by some other number. And so rather than thinking of this as counting by tens, I could just say 20, 40, 60, 80, and so on. And this would be 30, 60, 90, and so on. And we can actually see that right here. The ones that I've just highlighted and made yellow, that's a table that would be consistent. It was Antonio who decided to kind of go in between and count by something other than the ratio itself, and that complicates things. So really we could have just done 20, 40, 60, 30, 60, 90, and then continue with that. All right, so now let's take a look at Julian's ratio table. And before I go on, I recommend again that you pause the video so that you can fill in any notes that you missed. You don't need to bold or highlight the numbers that I did. That's just so that we can see the pattern of this is actually what it would look like if we were counting by just those numbers. All right, so for Julian, he also did good labels, and he started with 2. Okay, that's very different than what we have here with 20. So what we're going to do is we're going to put the same labels, cups of blueberries and cups of strawberries. And it looks like what he was trying to do, like it says here, is simplify or go backwards. So he started with the 20 and the 30. which he wrote as the third ratio. So you can skip these little dot, dot, dot parts and just go to the white areas. So he put 20 and 30 here. And we're not trying to criticize him at this point. We're trying to see how he can finish it. So 20 and 30. Above the 20, he put a 10, and then he put a 2 above that. So we can see that he's actually trying to go backwards, but it's not quite clear how he's going backwards. It looks like he's making the numbers smaller, but we have to make sure that he makes these smaller in the same way, which is division, rather than just like subtracting something. Like he's not just subtracting 10 here, he's actually dividing. So he's dividing by 2. He's taking half of it. And so he got 10 here, which means that he's going to need to get 15 in the second number here. So his question mark here should be a 15. Now we're going to find the first ratio. And we're going to start with the ratio we just created, the 10 to 15. So I'm going to put 15 over here. And we need to get from 10 down to 2. So if I count by 2s, 2, 4, 6, 8, 10, that's 5 of them. So I'm going to divide by 5. Can I count by 5s to get to 15? Okay, great. So I'm going to count by 5s to get to 15 as well. So to get to 10, it takes 2 5s. And to get to 15, it takes 3 5s. And so that means the original ratio, the simplest possible ratio in this entire thing, is 2 to 3. And that actually makes a lot of sense, because 20 to 30 is just like 2 to 3, but with zeros at the end of it. So basically, we're eliminating those extra place values. So now we're going to prove it here. We're going to say the original was 20 to 30, and we're going to simplify by the greatest possible value that can make both of them, which in this case is 10. 10 is the biggest number you can use to count by to get to both 20 and 30. If you tried something bigger, you could still get to 20, but not to 30 with the same number. Same for 30. You could think of bigger numbers, like 15 makes 30, but it doesn't make 20. These are the biggest numbers you can use to get to both of these two numbers of the ratio. And so then if I count by 10s, it takes 2 of them to get to 20 and 3 of them to get to 30. So this is our simplest ratio down here. Now we're going to find any other ratio. And to do that, you actually get to pick. You can pick the first row, you can pick the second row, or the third row. And it's completely up to you, because he's putting dot, 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 and so are we, which means that there's no specific number that you have to count by. You just have to make sure it's an equivalent ratio. So pick one of them, and then you're going to write the ratio here. So either you're going to put 2 and 3, 10 and 15, or 20 and 30. And then from that, you're going to pick any number at all, and you're going to multiply it by that number. It could be 5, it could be 100, it could be 7. It's up to you. Whatever you use, though, it has to be in both of these. And so I'm actually going to highlight this blue so that when you see it, the blue will remind you that you have to use the same constant number. Both of them have to be the same number, whatever that number happens to be. So again, you're starting with one of the ratios, and it doesn't matter which one you do. You could do in the first part 2 to 3, 10 to 15, or 20 to 30. You're multiplying by any number that you want, and whatever you get at the end should be your final ratio, and it should be an equivalent ratio to the original. I hope this was helpful. Please bring any questions as we talk about this in class during our next meeting.